In this final segment on discrimination in the workplace, we'll take a look at some of the various models that we can use to discuss levels of and the significance of different types of discrimination. First, let's take a look at, we'll take a look at models that tell us something about the level of discrimination. We'll take a look at a model that we think of when marginal revenue product of labor is greater than labor demand for a particular type of worker, which really is the same way as saying labor demand for that worker is less than the marginal revenue product of labor for the worker. And then we'll look at briefly at a quantity-led model for a utility maximizing firm, not a profit maximizing firm. First, let's think about this metric that we have brought about already, or we've thought about with respect to wages. In this case, I'm looking at the wage of females and the wage of males. And I'm simply using females and males as representatives of different types of discrimination, thinking I could just as easily have said the wage of the discriminated class versus the wage of a non-discriminated class. Supposing that females in our society over time have represented a discriminated class and males have not. It's not generally true, but certainly has been true in different decades, and some more true than others, and in some situations more true than in others. But we're simply using them as representative agents for a discriminated and non-discriminated class. So in this first, as we talk about the wage of the female plus some D here is discrimination. And it's a discrimination value in dollars. So the wage of the female plus D equals the wage of the male. The wage of the male being a full wage representative of marginal revenue product of labor, not being representative of any discriminatory practices. So when we see the wage of the female being less than the wage of the male, we know that there is some D that is present in that situation, assuming the male and the female have the same job, same level of productivity, same responsibilities, same skill set requirements. We know also that this D is important because it's a dollar value. It's not something more abstract. It's a dollar value that separates this discriminated wage versus the undiscriminated wage. And you'll see where the W plus D or WF plus D equals WM becomes a little bit more obvious as we look at a model or a couple other models here in a few moments. We have to recall that in the classic economic sense, discrimination only exists in markets where there are some mobility costs. This is presuming discrimination doesn't exist in all markets. So let's say that we have some markets, perhaps in the Northeast, where there are pockets of minorities that have concentrated more so than most other parts of the country. And in the Northeast, perhaps, there is some discrimination that we can observe in wage rates, let's say. And we know that if an employee feels disadvantaged, is not receiving a wage commensurate with their marginal revenue product of labor, the employee can always go to a different employer, to a profit maximizing employer rather than a utility maximizing employer. But in this case, if mobility is costly to go from one employer to another, or from one town to another, or possibly one region to another to find that non-discriminatory employer, then this D, this small d, some dollar value of discrimination as observed in the hourly or the salary wage, is hard to escape. So mobility costs very often play into this. We often suggest that if mobility is perfect, then we have no discrimination, we have no monopsony, we have no inefficiency in our labor markets. But we know the mobility is not perfect. Mobility comes at a cost, and that cost then will interrupt the efficiency of the labor exchange and labor transaction. We have to consider some metric that tells us about the power relationship or the level of influence in labor transactions. And so we use this ratio, and you've seen me discuss this ratio as I talked a little bit about the statistics of discrimination. You've seen me use this ratio before, wage of the female divided by the wage of the male. When this ratio is greater than 1, that suggests that the female actually is receiving a greater wage than the male. Again, we're talking about where it's the exact same job, exact same skill requirement, exact same productivity. We're trying to have apples and apples as closely as we can so that we can objectively measure this. So when this value is greater than 1, it tells us that there is some preference being given to females, and this was part of the issue that we saw within, or that we sometimes see within affirmative action. And again, female simply being a proxy for the disadvantaged class. When this ratio is equal to 1, it tells us that there is no observable discrimination. Well, if we think about this value with respect to U.S. employment of males and females generally, we know that the females are at about 76%, so this is 0.76. It's less than 1, which suggests that females have some disadvantage. But that's when we look at it generally. We see the number is approximately 94% or 0.94 when we look at males and females and the disparity in wages in a particular job, particular skill set, particular productivity. So there is much less discrimination observed, but there is still some. There is still some bias that's observed, and we know that bias is utility maximization rather than profit maximization. So it's important to think about when this ratio is greater than 1, equal to 1, or less than 1, and what that means. In the model I provided for you down here in the lower half of this slide, we get to see something about a market and labor supplies and numbers of firms when we have both utility maximizing firms, discriminatory firms, and profit maximizing firms or non-discriminatory firms. So let's suppose that we have a market in which there is a mix of these firms. We would believe then that that if there is a low number of discriminatory firms, a low number of employees that represents a labor supply in this particular market where we have some discriminating and some non-discriminating firms, a low number of workers in labor supply, we might have a labor supply curve that will come up and transect this line, this relation, where the ratio of WF to WM is 1, which means then that if there's a low number of workers compared to firms in this market, it means that those workers are all able to find jobs with non-discriminatory firms, such that the workers don't have to become subject to discriminatory or utility maximizing biases. However, in this same market, where we have the discriminatory firms and some non-discriminatory firms, if we have a high level of labor supply, large level of labor, recognize that this labor supply curve LHS is to the right of LLS, so it means a greater level of supply when it's shifted to the right. In the same market, some of those workers will have been able to find employment with non-discriminatory firms, but some of them will have been subject to finding employment with discriminatory firms. Simply a way of considering what the different market influences might look like. What would happen here then if we saw that the level of discrimination amongst firms reduced? Well, let's think first about why that might be. It could be a removal or a decline in ignorance, but it simply might be an increase in competition for workers in that market. So regardless, if we find that the level of discrimination amongst the discriminatory firms changes and improves, let's say, we would simply see that this part of the curve would shift as such. And the further it shifts upwards to become closer to parallel with or right in line with the original curve, the less discrimination is evident. And when I say the original curve, I'm talking the curve starting at 1, representing that wage female, wage male relationship. Well, what if that's not the case at all? What if it's not an issue of less discrimination amongst discriminatory employers? What if it's simply an issue of fewer discriminatory employers and more non-discriminatory employers? We would see this curve then comes outward, and then the discriminatory employer part of it the downward sloping part of it would be evident. So you can see different morphings, different changes in the way that we can model or describe markets using this WF over WM construct. And this is simply, again, the wage of the advantaged, the wage of the disadvantaged divided by the wage of the advantaged. If we look further at a relatively common labor market model in which we think of the marginal revenue product of labor being greater than labor demand for a particular type of worker, what we're really thinking about is the utility maximization that amongst the employers that might sometimes be mistaken for exploitation, or might even be synonymous with exploitation rather than simply discrimination. So I'm supposing a market here where we have both male and female typesetters. And on the right, I've given us the labor demand for male typesetters. I've given a marginal revenue product of labor equation for typesetters generally. I'm presuming that male typesetters and female typesetters have the exact same productivity. There's nothing about the job of typesetting that we can suppose would cause a male to have greater productivity than a female, assuming they have the same skill level, same preparation level, etc. So in this case, on my graphic on the right, the labor demand curve and the marginal revenue product of labor curve actually happen to be the exact same thing. And we've worked through several times now how we change this equation, how we morph this equation to see if it is going to be the same as labor demand. And that's if we simply change MRP of L and replace that, substitute that with W, and then rewrite the equation normalizing on L, or in this case this becomes labor demand. And if we were to do that, if we were to mathematically rearrange this and normalize on L, we would find that it would be L equals 230 minus 3W. So this curve is the exact same curve as the labor demand curve and the marginal revenue product of labor curve as we're dealing with male typesetters in this market. However, if we look to the left, we will see a labor demand for females that is less than the labor demand for males. It is shifted in and to the left. This marginal revenue product of labor curve on this model is the same as the labor demand and marginal revenue product of labor curve in this model. And we have a labor supply relation, which is dealing with the labor supply of workers generally of this type and this productivity level, the skill level in the market, male or female. And so we find that in this case, when we observe a labor demand schedule for females for a particular job that is less than the labor demand schedule for males of that job, we find some level of discrimination. There's no productive reason, there's no productivity, economic efficiency reason that this should exist. It is a reflection of some level of discrimination. And when we see that level of discrimination, we find that where we have labor supply equaling labor demand, that's going to give us the L star under that relationship, and that will yield our W star for that relationship, which is less than W star over on the right-hand model. So the wage for the male versus the wage for the female, given these demand relationship differences. And we find that for that number of workers, we would actually have a marginal revenue product of labor of 33. And we identified that by taking that number of workers that was found by equilibrating labor supply and labor demand in this model and plugging that value of workers, or L, into the marginal revenue product of labor equation. So as we did that, that gave us the marginal revenue product of labor of 33, which is 10 more than the 23 that in this case is going to be paid to these female workers based upon the labor supply and labor demand relationship. Well, how can we think about this in terms of the WFWD, or rather WFWM structure that we saw a few minutes ago? Well, if we think about WF divided by WM in this case, we're looking at 23 divided by 26. And 23 divided by 26 certainly is less than 1. In fact, it's going to give us a value of 0.88. So less than 1, we see some discriminatory influence. We can also think about this in terms of the metric of WF plus D equaling WM. So in this case, we have 23 plus D equaling 26, or D equaling 3. So we see then that there is a discrimination value per let's say that this is dollars per hour, that we can observe here, that actually leads to an inefficiency in this market. Let's look now at a slightly different market that's a little bit less intuitive as we describe and explain it than this one. And this is what we think of as a quantity-led market. You'll see here a lack of labor supply curve, a lack of an express labor demand curve. All we're looking at is a marginal revenue product of labor curve, and we're looking at different numbers of workers employed here. We have a supposition of some W star and some L star, which would suggest to us that there probably is some labor supply relationship. But then we have this LD that is lower than L star that yields some marginal revenue product of labor, which is going to be equal to W star plus some discrimination. Well, what we're suggesting here is that this is a market in which the firm simply chooses to hire fewer workers of the discriminated class, and in so doing create some inefficiency. In fact, we can think about this. We have the W star plus D is the discrimination. That's a premium that is being seen or observed in the marginal revenue product of labor that the employer is receiving. In this case, both the discriminated class of worker and the non-discriminated worker would be receiving W star. But we have fewer of them being employed, and so the discrimination isn't observed expressly in the hourly wage paid one versus another, but the number of them being employed, in which case we have some deadweight loss that we can think about developing here. And we know anytime there's inefficiency or deadweight loss, then we're not profit maximizing. And in this case, this would be clearly a utility maximizing decision on the part of the firm's managers or firm's owners.